Alrighty, welcome to the Unit 3 chapter video, the Unit 3 section 1.3.1.1. I know that's a little confusing as to why we've suddenly jumped to chapter 3. So what happened was, the first two sections we've talked about, these last 2 days, have been section 0. They've been sort of a lead-in. Now they should have been stuff you've seen before, and if not, that's okay, you're now caught up, right? So they were sort of an introductory chapter. Now we're jumping to chapter 3, as it indicates here, really our first chapter. The only reason we're calling it chapter 3 is because we wanted to coordinate to these workbooks we're going to start using. Now you may have gotten the workbook already, if not you will be getting it later. It's a fabulous workbook, has lots of great examples and lots of great problems that keeps the assignments really rather short for you guys, so it's to help you out with timing while still getting all of the math practice. That we really like these workbooks. The only thing is we didn't really like the order that they were in, so we kind of mixed up the order this year. So just make sure that whatever notes you have match to whatever workbook. If you want to think about 0 and 3 being one big chapter 1, that's fine, right? Okay, that's totally fine. You can think of this as one big chapter 1, but the workbook, quote unquote, that we'll be using is from chapter 3. Okay, so it's unit 3. If you just keep up with what's on Canvas and follow along with what's in class, you should be fine. It really shouldn't be that big of an issue. It just says 3 instead of 1, right? But if you do get lost, you can always go back to Canvas and find it there. Okay, this should not be the first page of your packet. Your first page should look like an objective tracker, right? So it should look like that big table that has the 4 sections, and then the 4 columns. The first one is section. And you'll notice we have 4 sections in this Unit 3. Section 1.1.1 is what we're doing in this video. So 3.1 is the first section of the book. It's got multiple parts to it. That's why it's 3.1.1 through 3.1.4. I know that's, again, very broken down, but we want to make sure we're all on the same page about where we are, okay? However, if you look in the main objective part, the main objective column, you'll notice that it's got properties of equality. You've got being able to solve with the properties of equality, being able to solve inequalities, and being able to solve exponential expressions. So it builds up, exponential equations. It builds off of what we were talking last time. Okay, the last 2 sections, we were dealing exclusively with expressions. Expressions do not have equal signs. So today we're going to start with equations and how to solve them. Alrighty, let's get started. 3.1.1, properties of equality. So let's say you have this expression. We'll call it 2x plus 4. Okay, so you have 2x plus 4. This is an expression, okay? Expressions cannot be solved, right? This is just a statement together. It's got coefficients, it's got terms, it's got constants, right? And it's something we've seen before, and we could simplify, but never, ever, ever are we suddenly going to know what x equals, right? X equals 2, or x could equal 5, or x could equal 8, or x could equal negative 16, right? So expressions cannot be solved. Let's leave ourselves a note there. So expressions, not solvable. However, once we take this expression, or once we have 2 or more expressions, we can set them equal to each other, and that we can solve. So if we take a look down here, we see 2 expressions, 3x minus 5 and 5x minus 4, and we've set them equal to each other. So now we know that this x is the same for both of these expressions. Now only one number is going to do that. There's only one number, in this case, that will work for both of these guys so that they end up being true statements. And we can use that fact to actually solve for that number. Okay? So you can solve equations. Solve. You can't solve expressions. It's very important to remember the difference between the two. So if you ever see solve the expression, you need to tell me, because that's a typo. You cannot solve the expression, okay? However, you can solve the equation, okay? So today we're going to be solving equations, linear equations. Linear just means power of 1. Power of 1. Power of 1 is linear. So we're not going to solve anything like x squared, x to the 4th. You'll be asked to simplify that stuff. Remember, we've been adding them and subtracting them and multiplying them, right? We did that last section. But now we're just going to be solving anything to the power of 1. Okay, so 3x minus 5, 5x minus 4, 2x plus 4, right? That stuff equaling, other stuff, or even things like 5. That stuff we can solve, right? So that's what we'll be doing in this chapter. Now there's some rules when it comes to solving. You probably actually know a lot of these, but let's run over these real fast, because you're going to need to know the names. Yes, I know there's a lot. There's 6 on this page, and then I think like 5 or 6 more on the other page, 7 on this page. But again, you know a lot of them. A lot of them make sense. Okay, you just have to remember what they're called. The first rule is called reflexive. It says that A equals A, or 2 equals 2, or 4 equals 4. It's really not that useful of a rule, but that's what it's called, reflexive. Then you've got symmetric. That one you're going to use a lot. It says if A equals B, then B equals A. Okay, so this first one up here. If A equals B, then B equals A. Meaning if X equals 2, then 2 equals X. Right? You can switch them around, right? So that's what the symmetric property means. And if you ever are solving an equation and you have an X like this, right? So in the very end it says 1/2 equals X. Then you can say by the symmetric property, X equals 1/2 and I am done. Right? So that's the symmetric property. Transitive property says that if A equals B, right? So if X equals Y and B equals C, Y equals 2, then by the transitive property, X also equals 2. So think of it kind of like the telescope method. If you've got something equal to one thing, and you know the middle thing equals the last thing, then the first thing equals the last thing, right? So think of it like, I don't know, hopscotch or however you want to think about it. But it builds down. It says if this is that and that is this, then this is this, right? So basically it just builds down and lets you substitute it. Sort of an extended substitute property. Those first 3 properties go really well together when you have an answer. Okay, so those are the first 3 properties. That's what they do. 9 times out of 10, they just kind of help you rewrite the answer. They're not super helpful when it comes to solving, but you will hear about them. Okay, so they're the reflexive, symmetric, and transitive. Cool. The next 4, you definitely know. Addition, subtraction, multiplication, and division properties of equality. Basically, it says you can add, subtract, multiply, or divide anything as long as you do it to both sides. So these are what I like to call the both sides property. These 4 are considered the both sides property. Whoa. Okay, hold up. Sorry, one sec. Both sides. So when we're solving stuff, like back up in our example, notice that they added 4 to both sides and they subtracted 3x from both sides, right? Every time you say from both sides, that's one of these properties here. And whatever you're doing is that property. So if you're multiplying to both sides, multiplication, property of equality, right? And it says that when you do that, you're not changing the equation, right? You're not changing the x value. It's okay to do that because you'd still get the correct answer. That's what it says. Alright, that's the first, and that's the 4 of those. And we're going to see those a lot, and you're going to know how to use them. I guarantee you've probably already used them before. The only thing is you got to be careful. You can't divide by 0, right? All of the abstract rules, all of the rules that go with multiplication, addition, subtraction, and division still apply even in the property. Alright, go ahead and flip the page to the next one. You'll see the last ones. We've talked about most of these. Substitution just says if you know that x equals 2, then you can plug in 2. Right, so that just says you can substitute in. That one is helpful much later on when we get to systems, when you can substitute in and solve for the other one. But you can do it at any point. If you ever want to check your answer, we could go back up to our first one, take that x equals 1/2, substitute it back in, and we would get a true statement, right? That's what it means. Just you can substitute. Commutative properties. Both commutative properties of addition and subtraction. Remember, that's the one where you can switch the order. So 2 plus 3 is the same thing as 3 plus 2. 2 times 3 is the same thing as 3 times 2. Notice there are not ones for subtraction or division, right? Because 2 minus 3 is not the same thing as 3 minus 2. Think of these as where they appear, right? So where the numbers appear, where they show up. You can switch the order that way, right? So you can multiply or add in any order that you want them to appear in the problem. We've also talked about associative property of addition and multiplication. Again, no subtraction, no division, right? You can rewrite those as, positives, right? Negative, or, like 2 minus 3 plus is the same thing as 2 plus negative 3, right? So you can rewrite it as an addition or multiplication, so you can get away with it, but there is no property of subtraction or division. The associative one says you can add them, combine them in any order. Okay, so you can add them in any order, or you can multiply them in any order. And it's not as they appear, like the commutative, it's in whatever order you want to put the parentheses around. You can actually combine them however you'd like. It's not going to change the outcome. So 2 plus 3 plus 5 would be the same thing as 2 plus 3 plus 5. And if we look at it, the first side, that would be 5 plus 5, which would be 10. The other side would be 2 plus 8, which would also be 10. So notice it didn't matter which way we started. We ended up with 10 equals 10, right? Same thing goes for multiplication. That's associative. Last one, we also talked about distributive property. We talked about that to death last time because that's how we multiply polynomials, right? Basically just says if you have something on the outside, you can rainbow it in. I like to call it rainbowing in. I don't know why it looks like a rainbow to me. I think it's fun. If you want to call it the wave or whatever you want, just remember it's distribution. Okay, so you're distributing each one in. As long as everybody gets paired up, you're distributing. You're distributing correctly. And that has one for both multiplication, or has one for multiplication over addition. So it only works if you're trying to multiply things that are being added. Now, again, you can kind of rope in subtraction to that one, but you have to be multiplying, is basically what it says. And those are all the properties. So notice, none of this is brand new. You should know every single one, but just in case you don't, they're all listed here for you. You might not have known that it was called the multiplication property of equality, right? Or you might not have known it was called associative property of multiplication, right? But you definitely have worked with them before. You've worked with adding things in different orders. You've worked with distributing numbers in, right? So today is really not about learning how to do new things. It's learning what they're actually called. And I know at the end of the day, some people think, oh, that's not important as long as I can do it. That is the biggest lie you could ever tell yourself. If you don't know why you're doing something, why the heck are you doing it? So make sure you start learning these names, okay? Let's head down to example number 1, see if we can work with these properties a little bit. But if any of these were confusing at all, make sure you stop the video and get your questions answered. All right, example number 1. Which property of equality is missing in the steps to solve the equation negative 7x plus 22 equals 50? Okay, so we've set up this table here. This is probably the stuff you've seen before, right? Okay, solve the equation. Sweet, moving on, right? However, now we actually have to do what we call justifying. Justifying. Why is it okay that you actually can do that? Why do you think it's okay? That's what you're saying. You're saying, I can do this because I know what property it goes with. I know that this is the blankety blank property of equality, okay? So it's not enough now to just say, I can add stuff to both sides because my teacher told me, right? Yeah, your boss is going to look at you like you're an idiot. But if you can justify it, then you're fine, right? So think this is like lawyer case. It's fun. Always, always, always start out with original equation. We've done nothing yet. So starting out with original equation. Now tell me, discuss it, let's take a look. How did we get from here to here? What did they do? Right? So it's a big game of what did they do? Well, they didn't touch the first term, right? That negative 7x. That term didn't get touched. The second one, though, it looks like the second term went away. What did they do to it? Did they add it, subtract it, multiply it, divide it? It looks like they subtracted it, right? So they took negative 7x plus 22 equals 50 and subtracted 22 from both sides. And that's how they got to here. All right, so what did they do? They subtracted to both sides. So what is that called? Subtraction property of equality. Notice I just abbreviated the heck out of that. Feel free to abbreviate the heck out of that as well. If you just want to write subtraction, PE, then that's fine. That's fine by me. But please include the property of equality, at least in my class. I know if you're looking at these in any of the other teachers' classes, then do what they say. But I like to tack on property of equality so that you remember it's just a property. It's actually a formal definition, not just I subtracted to both sides. Cool. No, it's actually the subtraction property of equality. But you're welcome to abbreviate the property of equality part since it happens so often. Okay. All right, so subtraction property of equality. Now let's just double check that they've actually finished this how they should. Let's go back and see what the next step was. So how did they get from here to there. Let's see. Well, negative 7x equals 28, and then all of a sudden they arrived at x equals negative 4. How did they do that? Well, did they add to both sides? No. Subtract to both sides? No. It looks like they divided on both sides, right, by negative 7. So negative 7x equals 28. Excuse me, I'm apparently losing my voice. Divide by negative 7 to both sides, and they ended up with the solution x equals negative 4. Now, because they divided to both sides, what it should say on the other side is the division property of equality, and it looks like it does. Sweet. So that's exactly how you'd set up this table. You start with the original equation, and then as you do stuff, you write it down. And eventually you end up with x equals something. Remember, if you end up with something equals x, you have to tell it in the symmetric property and rewrite it, right? So flip it around, which we'll talk about in just a sec. But that's basically how you set up these tables. All right, let's try another one. Let's try another one. Example number 2. Which property of equality is missing in the steps to solve the equation negative 3 minus x over 6 equals 4? So not something we're super familiar with, but let's see what happens. Let's see what happens. Excuse me. Now recall, when you're solving an equation, you always want to start as far away from the variable as possible, right? Because the variable is supposed to end up by itself. If you're trying to solve stuff right next to the variable, then it's going to be extremely confusing. Now, the only exception to that is a parentheses. If you have big parentheses and you want to take care of something, that's fine. But try as far away from the variable as possible. So right here, the thing that is the farthest away is the negative 3, right? And I mean the farthest away on the same side. So we're going to start by moving that 3 over, right? We add 3 to both sides. And when we do that, we get no more negative 3 on this side, and we get a 7 on the other side. That was the addition property of equality, just like they said. So that's good. Next, we have this. So now how are we going to battle this negative x over 6? Negative x over 6. Well, let's think about this. If I were to add that to both sides, then the whole thing would go over to the other side, and I'd be left with 0 here. And that's not really what I want to do. So instead, how did they go from here to here? What did they do? How did they get a 42 on that other side? That doesn't make any sense to me. How did they get a 42 over there? Ah, they treated this like a divide by 6, right? So they treated that as an x divided by 6. In order to get rid of a divided by, you do what we call countering, right? So you counter it with a multiplication. So they times by negative 6 to both sides. I'm sorry, they times by 6 to both sides. And they got negative x equals 42. Awesome. So when you when you multiply to both sides, what's that called? What's that called? Alrighty, that's called the multiplication, not a trick question, right? Property of equality, right? So multiplication property of equality. Fabulous. See, it's really not as ambiguous as you would think. It's not as tricky as you would think. Whatever you do is the name you put down, okay? So don't think that you have the names rarely are trying to trick you. They are trying to be easy. The multiplication property of equality talks about multiplication. Okay, it's the same with, I mean, obviously commutative is a word, like think communication or commute, right? You commute down the street, you're moving, right? Reordering things. I guess you can kind of think of it that way. Some of them are easier to tag than others, but this one, multiplication property of equality, pretty obvious we did multiplication, right? So it's trying to keep track of that stuff like that. And then the last one, we don't want negative x, we want positive x, so divided by negative 1 to get from here to here. That since we said divided by, we use the division property of equality. Fabuloso. Okay, example number 3, I want you guys to try it out on your own. You're going to do the same thing. You want to fill in this chart. What step was missing, what step was used to help solve 76 equals 5x minus 15 plus 2x. Go ahead and try that out now. Remember to pause the video if you've not done so already. Alrighty, so I hope you had time to pause the video, try this out, and find that missing property. Looking how they did it, they got all the way down to 13 equals x, and then they switch it around to x equals 13. And I hope you didn't just put your pencil down and call it a day, because that actually needed to have a rule. It was one of the very first rules we talked about, the one I told you you're probably going to use a lot today. It was all the way back at the beginning, symmetric property. If 2 equals x, then x equals 2. So what you should have filled in there was symmetric property, I believe it's of equality. Yep, of equality. Property of equality. Symmetric property of equality, which says if you've got one thing on the equal sign and the other on the, if you've got two things on either side of an equal sign, you're welcome to switch it. Equal sign can be switched back and forth, right? And that's pretty important, because when you think about it, when we talk about our inequalities later, that's not going to be true. 2 is less than 3 is not the same thing as 3 is less than 2, right? So symmetric property of equality, equations, that's pretty powerful, right? That's pretty important. It may seem on the nose, but it's definitely pretty powerful, right? All right, cool. Now we didn't talk about, one property they used, distribution property to combine like terms. That's when you have to combine stuff on one side. So remember, when we first talked about why like terms work, it was the distribution property. You can take that stuff out because they are like, right? So that's the property of combined like terms. Again, if you want to abbreviate it, you're welcome to. You can call it distribution. I'll write it down here. Distribution of combined like terms. Combined like terms. But I do want you, at least in my class, to start writing down distribution combined like terms so that you remember they are related. That's why we can do it, okay? At the end of the day, you can write CT, that's fine too. But I do want to see the distribution part. That's the important part. That distribution is why we can combine like terms. Alrighty, let's try one more. It looks like in this one, so example 4, what equation is missing from the steps to solve the equation 5x plus 3 times x plus 4 is equal to 28. Notice these are all equations because they have equal signs, right? We would never do this for an expression because none of our properties of equality work for expressions. Alright, in this one, it looks like all the steps are filled in, so what needs to be done? We're missing an actual work step. So we'll have to see, because remember, there are multiple ways to solve problems, multiple ways to solve equations. We'll have to see which one they're telling us to use, right? And remember, only certain steps justify our process. So we have to see what justification they've used so we can actually fill in the correct work. So let's take a look. We've got 5x plus 3 times x plus 4 equals 28. Looks like they first distributed, right? They distributed in that 3. And hopefully what they wrote down was distribution property. Ah, they did. Okay, good. So check on that one. Check. The next one, from here to here, it looks like they combine these guys to get 8. So it should say distribution property to combine like terms. Hopefully it does. Distribution property. Good. Check. Okay, check on that one. Now we'll have to see, okay, so from here to a blank, well, what do they want us to do? The next one says subtraction property of equality. What did the subtraction property of equality say? It says you can subtract stuff from both sides, right? So if you can subtract stuff from both sides, that means we're going to take this 8x plus 12 equals 28. What do they want us to subtract? Do they want us to subtract the 8x? That's a horrible 8, pardon me. Subtract the 8x, or subtract the 12, or subtract the 28? What would get us closer to x equals 2? Remember, as far away from the variable as you can. So the farthest thing from the variable would be the 12. So we want to subtract 12 from both sides. I don't want to write subtract 12 here, right? Because that's not what they're doing. What we end up getting is 8x is equal to 16. Alright, so that's what goes there. 8x is equal to 16. That was the subtraction property of equality. Now, if that is truly our answer, if that's what we should have, then our next step should justify as well. So from here to here, they say we should divide, use the division property of equality. So we should divide something to both sides. Can I divide something to both sides to get x equals 2? Yes, I can divide by 8 to both sides. So it looks like it fits in nice and easy there. So that is how you would plug in the work side, right? Just go along with the justification. Check. Alrighty. Last problem for this section. We're doing 2 sections today, but I'm going to do 2 separate videos. So last problem for this video. Solve the equation that follows. justify each step in your process. We talked about what that meant. Of using the properties of equality. Be sure to include the properties of operations if used, right? So be sure to use the operation ones, or the addition, subtraction, multiplication, division. Be sure to use anything you use. So I want you to set up that same table. Same table, use as much room as you need, right? And then I want to see on the left-hand side, equation. When I want it written a lot better than that. Equation. And on the right hand side we want to see steps. You can call it justification if you feel fancy, that's fine too, but I want to see it. I want to see it, everything in there. There should not be an equation here that does not have a step. Okay, so pause the video now, give it a wholehearted try, and see what you can come up with. Solve that equation. Remember, you should start by writing down the original equation. So this first one should say 5x minus 2 plus 4 equals 10. And original. From there, I let you guys have the reins. And remember, abbreviation's fine, but I have to be able to distinguish between distribution property and distribution combining like terms. And sim, right, should look different from sub for subtraction, right? So abbreviate in a way that you still know what you're talking about. All right, have at it. All right. I hope you paused the video, and I hope you tried this out on your own. Now, an important note is your answer may look slightly different from mine depending on what you started with, okay? This problem does have a little bit of wiggle room. While you always want to start as far away from the variable as you can, remember what I said about parentheses maybe being something you could tackle first, right? You can try getting rid of parentheses first. However, I'm going to stick to start as far away from the variable as you can, okay? So that's what I'm going to stick to. I'm going to start with the 4. So I'm going to subtract that 4 to the other side. I'm not going to actually do it in the problem like I always normally write it out like we did back up here, because I want this to be nice, clean equations. My steps, my step side, should tell you exactly what I did. Okay? So I'm going to use the subtraction property of equality. And when I do that, I subtract 4 to both sides. The 4 goes away. And I'm left with 5 times x minus 2. Subtract 4 to this side, I just get that. Subtract 4 to the other side, I get 6. Alright, that was my first step. Second step, I'm going to get rid of those parentheses. I think I'm going to use distribution property distribution property of multiplication over addition, but I'm just going to call it distribution property. Distribution prop. 5x minus, whoops, not 2, silly Miss K, 10 equals 6. Distribution property says I have to actually distribute it out. Another choice I could have had, I could have divided by the 5, right? That would have been fine. I could divide by the 5 and I'd be done. I would use division property of equality. So notice this is, it's got multiple ways to do this problem, and that's okay. That's okay. Regardless, we should arrive at the same answer. Alright, next I think I'm going to get rid of that negative 10, right as far away from the variable as I can. And in order to get rid of a negative 10 or a subtract 10, I'm going to counter with an add 10. So I'm going to use the addition property of equality. And I do that. I hit add 10 on this side. I'm just left with 5x. Add 10 on that side, and I'm left with, I want to say 16. Yeah, 16. I don't know why that took too long. Alright, so 5x equals 16. And then finally, I want to use purple. Get rid of the 5 part, right? It's the only thing left next to the variable, so it is the farthest away. So I'll divide by 5. I end up with, oops, sorry. Just write down division, right? Because that's what I'm using. Division property of equality. And I end up with 5 equals 6, or x equals 16 over 5 as my final answer. Awesome. Now, regardless of what way you should have you had gone, you should have gotten the same thing. We end up with 16 over 5. Fabulous. Okay. That is section 3.1.1. Like I said, we're going to do a couple sections today. If we have time for it, I'm pretty sure we do, though. So we're going to go on to 3.1.2, but if you have any questions at all about 3.1.1, none of these rules should have been new. Maybe you just probably didn't know what they were called before. And now you know, so now you must justify. All right.